Welcome to probability part 2. Our specific objectives here: how to solve probability using binomial theorem and the use of binomial distribution. The basic foundation in binomial theorem: if you have, let's say, a plus b raised to power 2, we have a squared plus 2 combination 1 into a power 1 b power 1 plus 2 combination 2 a power 0 b power 2 in this order. Just know the foundation. You can also use s as s squared plus 2 combination 1 s power 1 y1 plus 2 combination 2 l0 y square. It depends on what you are using. Now let us take questions from Examguide, using Examguide from past WAEC question and answer. Okay, let's use 2017. Bottles of the same sizes produced in a factory are packed in boxes. Each box contains 10 bottles. If 8% of the bottles are produced defective, find correct to 2 decimal places the probability that a box contains at least 3 defective bottles. Defective. Here is your choice either to use the binomial theorem or binomial distribution. For binomial distribution, n combination r into p raised to power r q raised to power n minus r is the format we use, where p will give us p of x equals 0, 1, 2, ... depending on the number, where the number ends. Like here now, our interest, how do you know your n? Read the question. They say each contains 10 bottles, meaning n is what? 10. So our n here is what? 10. But the r you are seeing is the question they will ask you. Just like they said, at least 3 defective bottles. P and Q represent success and failure. But in this case, we are dealing with defective and non-defective, meaning good one and bad one. It is still what? P and Q. So defective has been given to us 8%. So 8 all over who? 100 to give us 0.08. Let's 8 over 100 0.08. The next to produce is what? Non-defective. The non-defective is going to give us what? 1 minus 0.8. Okay, you can see the question clearly here. That is Q equals 1 minus 8 over 100, which is 1 minus 0.08 equals 1 minus 0.08, 0.92. I think we are ready for this job. So n combination, 10 combination. Let's interpret at least 3, mean probability of PR of 3, 4, 5, 6, 7, 8, 9, 10. You can see this is stress. What do? We will solve for at most. Now we'll have at least 3. We are going to solve for at most 3. Meaning 1 minus at most 2 will give us at least 3, the same solution. But if we start to solve this, it means we have to solve for 3, for 4, meaning we must occupy the whole places, then clean it and start all over again before we get to 10. So learn the secret of handling this in further maths exam, because most of the times we complain of time is because you lack the secret. Now, instead of doing at least 3, I will solve 1 minus at most 2. What I involve in at most 2, I have explained before. 0, 1, 2. If you count it, it is still jamming that 3. 1, 2, 3. Can you see it? But the only difference is 1 minus. Now I want to solve for probability of 0, PR of 0, which will give us 10 combination. Your R, which is 0, into P. Our P is 0.08 raised to power who? 10 into Q. What is our Q? 0.92 raised to power who? 10 minus 0. You punch the calculator to get the solution. 10 combination 0 is 1. 10 combination 0 is 1. Then 0.08 raised to power 10 exponent 0.00000 up to 11. 1 times 0.00000. 1, 2, 3, 4, 5, 6, 7. 7, 8, 9, 10, 11. And then 107. Multiply by 0.92 raised to power 10. That is 0.434388 times 0.12345678910910. 107. They give us 0.1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0.00000 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 4, 6, 4, 7. Let's see, calculate correct to at least 2 decimal places. 0.12. The rest cannot work. There's 0 here. Probability of 1, PR of 1. Then this one will produce a nice result. 10 combination 1 multiplied by 0.08 power 10 multiplied by 0.92 raised to power 9 plus probability of 2, which will give us 10 combination 2, 0.08 sorry, I think we're missing our R. Our R is, no wonder, this is 0 into 10 minus, okay, this one is 0. No wonder we have the complex zeros. Here, 1 times anything raised to power 0 is 1, multiplied by just this alone, 0.00. 12. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4. 0.92 raised to power 10. 0.43 4 3 4 3 8 8 4. Multiply by 1 to give us the same thing. So keep this one first. The second one, probability of 1, 10 combination 1, multiply by 0.08 raised to power r, which is 1, multiply by 0.92 raised to power 10 minus 1. This will give us 10 combination 1 is 10. 10 combination 1. Okay, 10. Multiply by 0.08, multiply by 0.92 raised to power 9, 0.7 0.4720 2161 times 10 times 0.08. This will give us 0.377 1, 2, 3, 3, 2, 9, 0, 9. Let's end it here. This for PR of 1. Probability of 2 will give us 10 combination 2, 0.08 power 2 times 0.92 power 10 raised to power minus 2. Okay, let's finish this one this way. We have 10 combination 2, 45 multiply by 0.08 square 0.0064 multiply by 0.92 raised to power 8, 0.51 321 887 3. Let's end it there. Times 45 times 0.0064. This is 0.14780 70354. Now 1 minus at most 2 will now give us 1 minus bracket. The first one 0.43438884 plus second one 0.3777299 plus 0.14780700354. Let's add them together. Plus 0.43438884 plus 0.3777299 to give us 1 minus 0.95992452. This will give us 0.0400754. Now the instruction is to 2 decimal places. To 2 decimal places. That is, after point you count to 1, 2. That is 0.04. You can see all this stress. The answer is just 0.04. That is the answer to that question. Now, if you want to use binomial theorem to solve, you have to create defective plus non-defective raised to power 10. But our challenge is going to be, it's also long, but let us bring it out. P raised to power 10 plus 10 combination 1, P power 9, Q1 plus 10 combination 2, P raised to power 8, Q square plus 10 combination 3, P raised to power 7, Q raised to power 3 plus 10 combination 4, P6 Q4 plus 10 combination 5, P5 Q5 plus 10 combination 6, P4 Q6 plus 10 combination 7, P3 Q7 plus 10 combination 8, P square Q8 plus 10 combination 9, P1 Q9 plus 10 combination 10, P0 Q10. You now come back to this. The question says at least 3 defective. So where did P start from? 3. Look at it. Meaning our interest from here to this side is none of our business. Now look at our business is this 10 combination 7 because P started from here, at least 3. Can you see it? To keep on going. You solve this, you keep. You solve this, you keep. Solve this, you keep. Also solve this, you keep. At the end, when you add whatever you have, it will sum up to this particular one. If not because of time, I would have just also used it and solve. You can see they are just the same thing. But it depends on the one you prefer. But the other one, solving from 3 to 10, don't try that one. It will take the whole of your time in exam hall. Okay, another one. An association is made of 6 farmers and 8 traders. If an executive, okay, this has to do with combination. If an executive body of 4 members is to be formed, find the probability that it will consist of at least 2 farmers. We have 6 farmers, 8 traders. Now, if an executive body of 4 members is to be formed, and let us check executive of 4 members, the total people we have there, we have farmers and we have traders. It's just 2 farmers, at least 2 farmers. We have how many traders? 8. 6 farmers, 8 traders, total people that are involved in an activity, they are what? 14 people, okay? Now a committee of 4, that is, you are considering your n. Just a committee of 4. Additional. But the question is, find the probability that it will consist at least 2 farmers. So the concentration is on 2 farmers. Total outcome here, total outcome implies 14 combination 4. You press 14 combination 4 to your calculator. 14 combination 4. 1001. 1001. That's 1001. Then at least 2 farmers. I have 6 farmers here. That is 6 combination 2 times 8 traders, 8 combination 1, or 6 combination 3 times 8 combination. Okay, we have committee of 4. 6 combination 2 times 8 combination 2. Then 6 combination 3 times 8 combination 1, or 6 combination 4 times 8 combination 0. There is something you consider in this type of probability. It's a technical one. Consider the number of committees you have. We have 4 committees. Now we have 4 committees. See, 6 combination 2, 8 combination 2. 2 plus 2, 4. Balance. Check to this point. 6 combination 3, 8 combination 1. 3 plus 1, 4. Then 6 combination 4, 4 plus 0, 4. So we are working on probability of at least 2. PR, at least 2 farmers, equals 6 combination 2 times 8 combination 2 plus 6 combination 3 times 8 combination 1 plus 6 combination 4 times 8 combination 0 divided by 14 combination 4. This is the probability. To give us what? Let's press 6 combination 2. 15 times 8 combination 2 28 plus 6 combination 3 should be able to give us the same thing as 6 combination 2. Okay, 20. 8 combination 1 should give us 8. Six combination 4, 15. 8 combination 0 should give us 1 divided by 1001. This will give us 15 times 28 420 plus 0 160 16 plus 15 1001 plus 160 plus 15, 595. All of 1001 divided by 1001, that's 0.594. 0.594. If you can observe what is going on, all the probability we have been solving will never exceed 1. It's just 0 point something. So the answer to this question is what? 0.594. Let us take another question so that we can call it a day for part 2, waiting for part 3. We are going to deal with normal distribution and the Poisson distribution. In a school, the ratio of those who passed to those who failed in a history test is what? 4:1. If 7 students are selected at random from the school, find correct to 2 decimal places. The probability that at least 3 students passed for the test is a similar question. I just want to interpret the one that of ratio, then I will allow you to tackle the rest yourself. And after that, I will expect you to go for more questions while subscribing to our channel. Okay, so this is it. A ratio 4:1. This implies the total is what? 5. For success, P equals 4/5. I've told you failure, Q equals 1 minus success, which is what? 1/5. The question is, at least 3 students passed the test. Before I will consider 3, let's see number of people that are here in a school. The ratio of those who passed is okay. If 7 students, so n is 7. Please try to get your n always. Now it's starting from 3, meaning we're going to solve 3, 4, 5, 6, 7. A lot of stress. So I will choose to go to failure. That's 1 minus failure at most. So this one is at least. I'm going for who? At most 2. Like what we did some time ago. At most 2, which are 0, 1, 2, 1, 2, 3. It will represent this perfectly. Instead of doing 1, 2, 3, 4, 5. Which time? You don't have such time in exam hall. Okay. So I've outlined what you need here because some of you, since it's a ratio, your mind will be telling you another thing. Look at your success, look at your failure. So for probability of 0, PR of 0 equals what? N 7 combination 0, P 4/5 power 0 times 1/5 power what? 7 minus 0. This is what? 7 combination 0. 4/5 times raised to power 0 is 1. Then this is 1/5 raised to power 7. To give us 7 combination 0 is 1 multiplied by 1 into 0.2 raised to power 7. Let's raised to power 7. 0.1234. 1, 2, 3, 4, 1, 2, 8. 1, 2, 3, 4. So this is what you have. Then PR of 1, probability of 1 equals 7 combination 1, 4 over 5 power 1, 1 over 5 power 7 minus 1, plus PR of 2. So what's PR of 2? 7 combination 2, 4 over 5 power 2, 1 over 5, 7 minus 2. This will give us 7 combination 1, 4 over 5 times 1 over 5 power 6 plus 7 combination 2, 4 over 5 r squared 0.2 raised to power 5. Let's interpret. 7 combination 1 is 7. 4 over 5, 0.8 times 0.2 power 6, 0.00064 times 7 times 0.8. Guys, multiply by 7 times 0.8 times 0.000064 plus, so the total for here is 0.0003584 plus 7 combination 2, 21, 21.2 power 5, 0.00032 times 4 over 5 raised to power 2, 0.640 multiply by 0.123332 times 21. No, 21 times 0.00032 times 0.640, 0.0043, then plus 0.0003584, 0.0046592 plus the first one 0.000128 equals 0.00467.2. Remember I said 1 minus at most 2. So 1 minus at most 2 here now will give us 1 minus 0.00467.2 equals 0.995328. This is the solution for at least 3 students passed the history test. God bless you once again. for being part of this class. For more questions, remember to subscribe to our channel so that you can see different types of probability and further mathematics and stop complaining.